Okay, so we're doing the last lesson, but really it's nothing new. First one here, it says, so just examples, combining all of the power laws or exponent laws that we've learned. So it says below is a student's solution for evaluating a power. Identify any errors in the solution and correct their work. So there might be more than one error. This is a little bit similar to one of the questions on the quiz yesterday. First thing you want to deal with when you're evaluating is make it a positive exponent, because really you can't evaluate with a negative exponent. Unless you had a calculator, and then it will get you the decimal form. So to do that, take a look. If I want to make that exponent positive, what did this student do wrong? They did something wrong, Hudson.
They didn't flip it.
They did not flip it. What did they do instead, which they thought was dealing with it? They didn't flip it, and they did, what did they get rid of? The negative. So they kind of thought, oh, I'm going to take that negative and multiply it, I guess, to make it a positive. And they figured that was taking care of it, but it is not. So over here, let's do what should be done. We need to keep it negative and then flip a fraction. Okay. Negatives for a fraction, they're either shown out front or up top. Either way, you can move it to be out front. So now I flipped that, and now it should be raised to the 5/3. Okay. Now from here to here, did they do that part correctly? Forget that what the question was. Did they do that arrow step? Yeah. So they put it in radical form correctly. So we're going to do the same thing, but with the correct fraction. Okay. And so then, did they take the third root of 64 over 125 correctly? What's the third root of 64? 4. Yep, so they did that. Did they do, what's the third root of 125? 5. So they did that correctly. For us, though, the correct answer, we need to have it to be negative 5 over 4, right? We're just following through to see if they made any more mistakes, carry through errors, you might call it. So here, that's what it should be. And then we raise everything to the exponent 5. Did they? You might want to get out your calculator just quickly. 4 to the 5 is, that's correct, yeah. And then 5 to the 5. So they did that part correctly. So they did that, they did this, they did this. It's a wrong answer because this was incorrect, right? So that was wrong. For us, it's going to be negative 3,125 over 1,024, because a negative raised to an odd exponent will give you a negative answer. Yeah. It is, the whole thing is negative. You just need one negative sign. If you put it in both, then it's really positive. Nope, it doesn't. At the end, though, you either want it up top or out front to be in proper simplified form. You wouldn't want to show it like that with the negative in the denominator. We typically, that's not simplest form if you have a negative in the denominator. But you can show it up there out front or up top, just not down there. Okay. It's not a different value. It's just, yeah. Okay. All right. Okay, so now we have to do our own work in this. We're not checking anyone's. So, fraction. You might want to, and I kind of recommend, you do the numerator first before dividing in this case, because there's a few things to do in the numerator. Within that, take a look within the brackets. Well, there's no common basis, so that within the brackets, there's nothing to do, either set. But now the first bracket is raised to the exponent 3. So we've got to raise everything in that first bracket to the exponent 3. So power of a power, you multiply the exponent, so that's x to the 6. Remember, if it's just y or z, it's got an exponent of 1. So that's going to be y cubed, z cubed in the first bracket. Copy out the second bracket. Copy out the denominator. Oops, I just moved something. That's okay. And now finish off the numerator and then divide, or you could now do everything at once. So we've got x to the 6 times x. Remember, that's x to the 1. Okay, so if you do it in 2 steps, that's x to the 7. Y cubed times y squared is y to the 5th. And there's nothing you can simplify with z. Okay, so I'm going to actually try to move that down. Okay, and then just copy out x z squared. And now dividing x to the 7 divided by x, remember that's an exponent of 1, so that's x to the 6. Y to the 5th, there's nothing to simplify. And z cubed divided by z squared is just z. Okay, try to put an equal sign on each line of your work. I noted that on your quizzes yesterday. Some of you just put the answer, plopped it in there, put equals each line and try to make it underneath each other. Obviously, we ran out of space there, so I do an arrow. Yeah, try to put the equal sign underneath. Now, if you wanted to do it all in one step after the power of the power, you can see that you'd be going x to the 6 times x to the 1 divided by x to the 1. So that's just x to the 6. Y cubed times y squared stays. Z squared cubed divided by z squared you could do right away. So you don't have to show that this step here. Okay, now next one, what I've been saying all along is try to do within the brackets first. And so you'll see some A's and some B's, right, that you can simplify. And once you do that, you can square it. Now you do have the option is that you could square everything first and then simplify the fraction. It's going to work out the same because really squaring is the same as a repeated multiplication. So either way works. I'm going to keep to that same way I was mentioning. So looking, I still need brackets. I still need the squared. But now think about a to the 1/2 divided by a to the 3/2. I have to subtract those exponents. So what's 1/2 minus 3/2? Fractions. Do it in your head. Common denominator. Hands up. Step. Nope. Think again. Careful, careful. Yep. Positive or negative? Negative 1. Yeah. Right? Because you're going 1/2. You have $half, and I'm taking away, remember, 3/2 is $1.50. So you're in debt $1. Get -1/2. It's already got a common denominator. So that's going to be a to, oh, sorry, did I say, what did I say? That's -2/2, which is -1. So that's going to be a to the -1, b to the -1. 4 minus 5 is -1. So you've got to remember your integers. You could convert them to positive exponents right now, or I'm going to square everything. Now I have to represent with positive integers, positive exponents. So both factors have negative exponents. So they have to both, this has to go in the denominator and this has to go in the denominator. What's going to be up top? 1. Not 0, not A, not B. It's going to be 1. Because this is like 1, a to the negative 2, b to the negative 1. So 1 stays there, a squared, b squared. Okay. Okay. Next one in C, it's a fraction, but now brackets are in separate parts, right? So the numerator is raised to the exponent 1/2, denominator exponent 3. So you have to do them separately. So 25 to the 1/2, we'll think about that in a sec, because that's 25 to the 1. A to the 4th raised to the 1/2, you're multiplying the exponents, so that's a squared. And c to the 1 to the 1/2 is c to the 1/2 overall. Sorry. Okay, that's the numerator. Then the denominator, don't forget about every factor there. That's a cubed, b cubed. Every factor gets raised to the exponent 3. Now we want to simplify any of the numbers that we can and obviously use our power laws. What's 25 to the 1/2? Who remembers? Tolu? 5. Good. It's the same as square root of 25. Then a squared divided by a cubed is a to the negative 1. C to the 1/2, there's no other c's. And there's no other b's. I'm just going to leave it in the denominator because why not? That's where it's a positive exponent. Leave it there. And so now I only have to deal with the negative exponent. So that just, oops, I want it to be red, sorry. Just this has to go in the denominator. And I don't need to show it with a positive 1. If you just show it as a, that's the same as a to the positive 1. Now you could, let's take a look. Did it say to use radical? It doesn't say. You could also give it to me like this, 5 root c over a b cubed, just because you know exponent of 1/2 is the same as square root. So I'd accept either one. Okay. Okay, so this next one's got a fraction in brackets raised to the exponent negative 3. I've said before that maybe we should simplify that fraction first. But up until now, those fractions didn't have negative exponents. So what I actually would recommend right now is to make sure that that's a positive exponent on the outside. So I'm going to flip the fraction and make it a positive exponent 3. So that's going to be 12xy squared z over 36 x to the negative 2 y z to the 5. Biggest thing to realize here, when you're flipping that fraction, it's not changing any of the exponents on those variables. I changed the exponent on the outside. Okay, can phones go away, please? Earbuds out. Okay, so here, now I'm going to simplify within this. So this first step is to deal with that negative exponent. If I reduce now, I know that 12 goes into itself once, into 36 3 times. and then I deal with the variables. So x to the 1 divided by x to the negative 2 is it x to the negative 1 or 3? 3. Y squared divided by y to the 1 is just y to the 1, which is y. And then z to the 1 divided by z to the 5 is z to the negative 5. Now if you, negative 4. If you know that there's going to be z to the 4 in the denominator, you can leave it there. Because right now the only thing is 3. I'm taking 2 steps for that. Okay. I'm writing really big. Hopefully you can fit it in a little bit smaller. Now I have to cube everything. Every single thing in that bracket. So that's going to be x to the 9, y cubed, z to the negative 12 over 3 cubed. And if you know what 3 cubed is, you can do it right away. Happen to the y? The 1 is up there with the x. It's understood to be a 1. The 3 is in the denominator, right? The 3 is in the denominator. It stays there. Okay. So now the z has to go into the denominator along with the 3 cubed. So we'll have x to the 9, y cubed over 3 cubed is 27, z to the positive 12. Okay, so that's the last example we're doing together on this. You can start on the practice while I'm handing back your quiz, and then we'll take that up.